Okay, so in this tutorial, I'm going to try and do a basic survey of some 3D modeling skills in Rhino. So I'm also going to try and keep a label down here so that it's easier to kind of navigate through the video and reference different parts. And I'm going to try and just start with some basic things. So here in my file, the first thing I'm going to do, first thing you always want to do is check on your units. So I will type in units in the command line, change into feet. Okay, I'll just say yes. Okay, and I got a bunch of stuff in here that I'll just kind of hide for the moment. So in case you didn't know, a really good tip for navigating in Rhino is that you can hide and show things. So if you go to this tab up here where it says visibility, and I'm going to use the command hide right now, so everything I had selected just then is hidden. So I'm going to just introduce planar surfaces first. And what I'm actually going to do is I'm going to work in the top viewport, and I'm going to hold Control and Shift on the keyboard and right-click my mouse, and then drag my mouse to tilt in my viewport. Now I'm in like a 3D view in my top view, rather than working in my perspective view. And the reason for that is, so if I drew a box just there, you'll notice that as you're working more and more in Rhino, when you start to try and orbit in 3D view or zoom in and out, things will kind of fly out of your view. Or you won't be able to zoom in all the way, or you'll zoom in really fast and things like that. And so, first of all, top view is a little bit easier to navigate in because you can always zoom. So I prefer to work in top view. The other thing that I find really useful, and you'll see me do it probably a bunch of times, is to zoom to an object. So if you select an object and you type in the command zoom, one of the options I have here is to zoom to selected. So if I click on selected, you can see I zoom to it in that viewport. Now, when I move around it, it's the center of my orbit. So, so I won't have issues with it kind of flying in and out of my viewport as I try to orbit around in 3D. So anyway, so I'm mostly going to work in top view. And I think that's the easiest one to work in, but you're welcome to do whatever. The other thing that you'll probably see me do a lot is toggle between display modes. So up here in the top left, there's a menu drop down for each viewport. And the first set of options, and these are only, you guys will probably only have these ones, those are the defaults. But the first set of options here are what are called display modes. And so the standard one, I think, is wireframe. Obviously, that just shows you things where you just see like edges of surfaces of 3D objects and so on. And then shaded is the one that I'll work in the most, and that shows objects that are surfaces kind of as solid, as opaque. Some people also like to use ghosted. That's kind of a balance between shaded and wireframe. And then I think rendered is also quite useful because it kind of shows shadow, and it shows a little more definition on the surfaces. You'll see what I mean later on. But for now, I'm going to start working in shaded mode. So like I said, I'm going to start by just drawing a couple of basic surfaces. So most of the surface tools you'll find obviously under the surface button here. If I want to draw any kind of surface plane or planar surface, I'm going to use the, so each of these buttons over here is, there's a button kind of on the surface, and if you click on the corner of it, you'll find that there's a bunch of other tools kind of hidden underneath that button. So the most basic version of this is the planar surface. And you can see it just asks for 2 corner points, and it's going to create a surface planar to the orientation plane of whatever viewport you're in. And so this critically is different from a rectangle. So a rectangle is just a curve. You'll see when I select it, it says 1 curve added to selection. And this is something called a surface. So this actually kind of has like it's filled in. It kind of has like a physical It's sort of like more like a physical object, and this is more like a line. So the most basic version is obviously to draw just kind of planar surfaces. A lot of different ways you can do that, which I'll cover. But also, if you want to draw kind of like tessellated surfaces or like a folded surface, something like origami, one of the best tools for that is to draw like what's called the 3-point or 4-point surface. And so it's also just called surface point or surf. Surface is abbreviated to SRF always in Rhino commands, and point is abbreviated to PT. Curve is abbreviated to CRV. That one's actually not, but you see interpret curve is abbreviated to CRV. So in order to draw a point to draw a plane that's like a rectangle, like a triangle, we want to use this command surface point. And what that will do is allow us to click, and we can do it for 4 points too, right? So again, we're making planar objects, and we can make a triangle by just clicking the 4th point back on the original point. And so that's the easiest way to make triangular planar surface. So I'm going to delete those. And let's say, for example, I wanted to make like a kind of folded origami style module. What I would do first is I would make a rectangle. So I'm going to use the rectangle tool. I'm going to type in a distance. I'll just make it 10 by 10. And then I'm going to make a triangular surface. I'm going to make a series of triangular surfaces using that command inside this triangle. So once I have a couple of them, I can copy them. I'm just using the mirror command here. Notice I have the option copy set to yes. And I'm holding shift to snap to ortho, so I know it's like aligned, those edges are aligned. And then if I was to select all 3, I could also mirror. Holding shift, click. Okay, so now we have a bunch of triangular surfaces that are just like planar with each other. But one of the critical ways of manipulating surfaces is to use something called control points. And so if I select all these surfaces, and I'm actually first going to delete my curve. If I select all these surfaces, I can turn on something called a control point, which is basically like the points that I just clicked in order to make these surfaces. So when I click that button, points on, you'll notice that some little points have appeared at the vertices of all my triangles. And I can actually grab those now and move them around. So I'm holding shift to select multiple points, and I can move them around in 3D in order to redistribute the corner points of my triangles and make them into this more 3-dimensional surface. Now, if you wanted to manipulate them in a precise way, what you would do is rather than using the gumball thing, so I'm selecting those same 2 points, and I'm going to use the command move. And in the command move, so obviously when we select something and we move it, we can use shift to snap to ortho, and we can move it like in the plane that our viewport is in. But we also have the option to click vertical. And so when I toggle vertical to yes, now whenever I click, you can see that my movement is constrained only to the Z dimension. And so, for example, if I wanted to make a folded plate structure with a specific size, let's say I want these points to be 5 feet above the bottom points, I can move them by a precise dimension that way. And I'm not going to do it again, but I can do it for these guys too. So you can make a simple kind of folded module that way, kind of by starting with a planar drawing and then moving the corner points vertically in the vertical axis by a specific amount. The other thing that I wanted to talk about is how to make a surface that's three-dimensional like this, but that isn't um, like made out of triangles. So for example, if I wanted to make a partial hyperboloid surface, I'm going to draw first using the polyline tool. So I'm just going to click somewhere in my viewport. I'll enter a certain distance, and I'll do it again. And actually, let me change my title for a sec. Okay, so I realize this is actually based on a slightly different shape. So it's based on a triangle. Rather than use a polyline to make the edges, I'm going to use a polygon. I just use the command polygon to make a triangle. I'll change the number of sides to 3, which it's already set to. Okay, and then I can draw a triangle of a certain size. So there's the kind of surface. And then if I wanted to make the additional point to interpolate my my paraboloid through, I would go rotate 3D. So rotate 3D works just like rotate, except that we can set a rotation axis. So for example, I'm going to click on two edges of 2 points of one edge of this triangle, and I have the option to copy set to yes. And I'm holding shift to go 90 degrees. You can also just type in 90 degrees. Okay. And so we've rotated and copied that triangle along one edge. So we've gone from a triangle that's totally flat, planar, to vertical, like that. I'm going to move this up so it's a little easier to see. Okay, and so in order to make that surface that I described, we could use the same command, 4-point surface, and I'm going to go through every point. And so you can see that so that it automatically kind of created that geometry. And then because it's based on the triangle, we could move it around, we could mirror it to create that surface. Right, I'll show it to you in rendered view here. A little more clean. And then, depending on how you wanted to arrange it, you could make several of them. You could do them as well. So that's kind of the basic two-directional curve surface using the same tool. Okay. Okay, so the next thing we're going to look at is how to make kind of more of a free-form surface. So what I mean by that is just kind of a surface that you manipulate like we did before using control points, but just to make a looser kind of style of geometry. So if I go into the plane button here, I'm just going to get a regular 2-point plane, and I'll draw it up here. So like with our triangles, if I turn the control points on, or that command points on, you'll see I have 4 corner points, and if I move any of them, it'll stretch my surface just like it did with the hyperbolic paraboloid. That's one way that I can manipulate that surface. However, if I wanted to make a more complex geometry, then I can basically add points. So there's a command that you'll find quite useful, which is the rebuild command. So I'll type in that word rebuild. This can also be used on curves, by the way, and other types of geometry. So there's a couple different things that are important in here. The first thing is the number of points here. So if we look at up here where it says point count, it'll give us a number of points in the U direction and a number of points in the V direction. And if I kind of turn this way down and click preview, You can see the u and v of a surface is kind of like its own miniature coordinate space that's like defined to the surface. So in the same way that our plane here has an x and a y dimension, surfaces have like a u and a v, right? So the number of subdivisions in one direction or the number of control points in one direction is controlled by like the u, and then the number in the other direction is controlled by the v. If we change those numbers and kind of balance out how many subdivisions we have to get a relatively even grid there. The other thing that you'll notice is this thing that says degree. So basically you want that to be, if you want a curved surface, you just want that to be. Anything that's like got sharp edges, that would be a one-directional curved surface. So basically it doesn't have a degree of curvature. But if we want it to be kind of curvilinear and fluid, we want it to have a degree of 3. So it should change to 3 by default, but that's just to let you know you don't need to mess with those numbers. And the rest of the stuff you can also leave as default. And again, you can click preview each time you change something to see how the changes are reflected. So now if I click OK, you can see that when I select that surface, it looks a little bit different. It's got more lines kind of within it. And likewise, when I turn the control points on for it, you can see I have a whole bunch more control points than I had before. And just like when I manipulated the triangle, I can select those control points and I can move them around. And I'm just going to drag them up and down in the z dimension. And so that's one way you could kind of manipulate a surface. Now, obviously, this surface kind of has a lot of control points, so we could go back. Try that. Viewer. If you wanted to do something kind of simple, switched into wireframe there so I could easily select these points. If you wanted to do something simple, kind of like that, you could start to manipulate and create more kind of free-form surfaces. Now, this is also something that's pretty useful for kind of modeling like a ground plane or, a topographic type of surface. So along those lines, and let me change the title real quick, we can also generate really kind of precise free-form style surfaces like this one using some other commands. So I actually have over here, I have a collection of topography lines from another project. If you want, most of the time you can find a topography map of a location, or there are ways to actually get them in terms of like a vector format and bring them into Rhino as curves, or you can do like what we did in the aerial image tutorial and bring in a map and trace it. And then what you want to do in order to, if I wanted to make these lines, these curves into a three-dimensional surface, what I would have to do is I would have to move them all in 3 dimensions kind of into the position. So I'm going to delete this, at the correct height. So if you know how a topography map works, basically these are like contours. They're like lines that represent where a surface is at a certain height. And so these numbers represent kind of what those heights are. And so if you wanted to, once you had the lines drawn in 2 dimensions like this is, so that's just, these are all flat. I could start from like my lowest point, for example, looks like 9 is the lowest point. And I could do a move, vertical, move them by 1. And then basically you would go incrementally and deselect lines and move them up by 1. until you had kind of everything positioned at the right location in the z dimension for where you wanted it to, and you didn't actually select the text if you forever. Anyway, so you can see we're starting to make this, starting to make the curves show up in 3D. So, so what I have over here is the same set of curves already kind of positioned in 3 dimensions. And so you can see the curves themselves start to like, show, like represent the surface. So what you would do if you wanted to turn this into a surface rather than just have it as a set of curves in 3D is you could take the, oh, actually, I'm sorry, I didn't mean to do that. So one thing that's helpful to do when you're using this technique is to make sure that you have all the edges like touching the boundary of an object, and I'll show you why in a minute. But basically, you take all the outlines that are positioned in 3 dimensions, and you just use a command called patch. Like that. Okay, and so what patch will do is kind of interpolate a surface through a set of contour lines, or through a set of lines of any type. And we have a bunch of things we can control here. If I click preview, you can see that it's pretty accurately kind of fitting a surface through those curves in 3 dimensions. Now, if we wanted it to be a little more precise, we could step up the stiffness, and you might find that that works a little bit better. And you can also do kind of like what we did before when we rebuilt the surface. We can up our number of kind of subdivisions in the U and V direction. Now, you should be careful with this because the higher you go, the more likely you are to kind of crash your computer or slow your computer down. You can see it's taking a lot longer to calculate there. So I'm going to keep mine at 40. But if you wanted to get more precision, if you wanted to fit the surface to the curves more accurately, then you could crank those numbers up. I'm going to go ahead and click OK. So now I have that surface right there. And if I select that surface, you can see it has all those grid lines through it to represent the number of control points. And likewise, if I had the, if that control point's on, you can see I have a number of control points that kind of define that surface. Oops. Okay. And so if I wanted to trim that surface, like I said, I could start from the outline that I created. The other option that you have is to select the topography lines. So I just selected from left to right, remember, only select things that are inside my selection window. And then I can use a command called bounding box. And what that will do is it will make a box around my geometry, kind of like at the extents of the geometry. So you can see that the highest curve is also where the top of the box is. The edges of the curve are all along one side of the box, and so on. So that's how I could kind of get that outline. And then if I wanted to trim away the box, so my surface is actually going through it above and below because it's kind of interpolating, so it's swooping up through the surface. So what I would do is I would just scale it. You can scale 1D using the grips on the gumball tool, or I can go scale 1D to just make it like taller. Go from the midpoint of the vertical edge of the box, scale it up like that. The other thing you could do is you could just use the edges of the box and trim the surface that way. So I can go dupe edge. So dupe is short for duplicate. You can see there's a bunch of different duplicate commands. And in order to retrieve like an edge of a surface as a curve, so if we wanted to turn this edge of the surface back into a curve, I can hit dupe edge and I can select those 4 edges of my box, press enter. Now I'll move them out of the way. You can see they're individual curves. I'll delete that. Delete that. And if I wanted to trim my surface with that, so in Rhino, you can trim an object with a curve based on how you're looking at it in the viewport. And so if I were to select those 4 curves and then type in trim, you can see it would project, basically project that outline onto my surface and trim it perfectly to that surface. Of course, we could just use the box as well, trim it with that. So trim, I already have my box selected. That's my trimming object, the thing I want to cut with. And then what I want to cut away is the kind of loose edges of my topography. And there we go. So then I've trimmed my surface down. And so then you would have that kind of topography surface as a 3-dimensional like surface object. And remember, we could still rebuild the object and reduce the number of control points if we wanted to make it a little bit easier to manipulate. So obviously, the fewer number of control points, the less accurate my surface is, but you can see right there. So if I undo that, I'll do it one more time for you. Rebuild. And instead of delete input, I'm going to keep both surfaces. So you can kind of see the difference, like how precise one is to the other. Well, and actually, I think preview will kind of show you that as well. Maybe not in surface. So if we turn it up, get a few more points. Okay. Now you can see that's quite a bit closer. Okay. And so then I could actually, again, turn on the control points for that surface, and I could start to manipulate my topography surface if I wanted to, you know, kind of change the nature of the ground plane relative to like a structure or something like that. So that's one way to deal with ground planes. Okay, so now we're going to deal with a different kind of surface, which has to do with kind of like making like strips or ribbons or like ribs to form a structure. So there's a couple ways to do that. Really, the simplest way would be to like draw a set of curves in 3 dimensions and then use that to create surfaces from. So the best way to draw a curve in 3D, for example, if I wanted to draw an arch, what I could do is I would go to front view. I get in here where my origin is, and I could use the arc command and go 0, 0, and I could draw an arc of some radius like that. That's obviously way too big, but anyway. And so I could make, if I go back to top view now, you can see that that arch is kind of like vertical. It's set up vertically in space. So I could use that kind of curvature for making a surface from. The other types of curvature that I think are really useful are going to be like the interpolate curve. So up here we have the polyline, which, as you know, is like a kind of collection of straight lines that are joined together as individual segments. And then we have 2 other kinds of curve here that are more freeform. So one is like it's kind of like a spline curve, if you're familiar with that. But basically, when you draw using just the curve command, it works like a Bezier spline. So you can see that the control points, and just like with surfaces, curves also have control points that kind of define their geometry. And so you can see that when you move the control points around, it changes the nature of the curvature. And so when you're drawing a curve, literally based on those control points, that's just the curve command. But that actually makes it quite hard to predict like what the curve is going to be as you're drawing it. So it's a lot easier to actually use a command called interp curve. So that's the one right underneath this curve command called interp, which stands for interpolate, and then curve, CRV. And so that guy is going to draw a curve through the points that you actually click in your viewport, like that. So that's another way to draw curves. And you can see when you select it, it still has the same control points. However, if you wanted to edit those points like we just had been doing, if you wanted to use the points that were actually on the curve, there's another type of edit point. It's actually just called edit points. And you can see when I clicked that, I now have the control points that are actually on the curve, and I can move them around. The same type of points that I used to originally draw the curve, I can edit the curve with like that. And by the way, you just hit escape to make those points go away, either type of point. Just hit escape on the keyboard. Okay, so if I wanted to draw an arch, like a symmetrical arch like this guy, using that command, what I might do is like draw like a construction line. So if I drew a vertical line at a dimension of 10, and actually I should be careful here because I'm not drawing on my plane. See, I'm kind of behind the plane, so let me restart that. If I draw a vertical line, and I'm just going to start at 0, 0, and I can do that by, instead of clicking in my viewport, I can just type in a coordinate in the command line. So 0, 0 is going to be at the origin of our file, right? That's our XY coordinate. And then I can type in a length for that curve and press enter. Now I'm holding shift to keep the line straight vertical. So now I have a kind of construction line. And then I could do the same for the width of my arch. So over 5. Okay, and so what I would do here is I would use that same interp curve command. Oops, and let me just copy this to both sides. And I can do this kind of thing. Draw an arch like that. Of course, you can also, you can give yourself like more points. We wanted our second line to be like there. You control like the number of control points that define the curve. The other thing you can do, which is a little simpler, is instead of drawing it as one arch that's kind of symmetrical like that, you can draw it based on tangents. So if I use the same command, interp curve, and right here in my options, I have this button, Start Tangent, and I can click on that guy, and I can choose to, so I've selected the point where my curve is going to start, and then in order to set the tangent, or basically the direction that my curve is going to be going at that point, I'm just going to click on the button Direction. And I'm holding shift, and I'm clicking up like that. Now you can see wherever I go, my curve is going to start by drawing in that direction. And then in order just to keep it simple, I could again do an end tangent. And I'm going to click on that high point of my arch. Again, I can choose the option direction. And I'm holding shift and I'm drawing straight horizontal. And I can draw or finish drawing my curve there. Because once I do that, I'll just use the mirror command, mirror it across my axis, and then I have a symmetrical curve. So I could join those two curves using the join command, and I would have one symmetrical curve. I think you could do it too. I don't actually know if this is true, but maybe if you change like how long these original tangents are, it should change. I guess it doesn't. So what you can always do, you'll notice that when you've drawn a curve like this, where the end and the beginning are defined by a tangent, you'll notice that the control point directly adjacent to that curve, once you've drawn it, is always in line. It's like aligned with that tangent, right? So basically, in order to change how strong those tangents are, we just move these points in the same direction with the original direction or tangent of the curve at that point. So we can kind of edit the geometry a little bit that way once we've drawn it. And then I could mirror it like so, join it again. So that's a way to draw like a less even arch type of curvature. And then the other type, or the other two types we might do are the parabola. For that, we can draw, we know that's a specific type of curvature, and we can just type in the command parabola. And I think this guy works. There we go. So it's going to ask you for like a focal point, which is kind of like a radius in a sense. It's like a central point. And then it'll ask you for the endpoint. And then you could always do scale 1D. And you can see that's actually the basic type of curve that this Bezier produces. So that's how you would draw a parabola. The other type of curve that you might use, which goes hand in hand with some of the physical modeling techniques, is the catenary curve. And this one's a little bit trickier. In fact, let me try and, I think you have to make a symmetrical one for, oops, what did I just do? Let me copy that. So again, to copy, I just type the word copy in the command line. Okay, so catenary, so start of catenary, and axis direction, which I think is straight. And then it'll ask you for a length. I think maybe you can go mark apex. Okay, so you can just draw it at some dimension and then scale 1D it. So I guess mark apex just created a point at the high point. I don't need that. I'm just going to delete that. Again, I'll go scale D, and I'll scale from my central axis at the bottom to the midpoint of the curve. And that's how I get it at the height that I want. And you can see that a parabola is actually a little bit different from a different type of curvature from a catenary curve. They're a little bit different. Okay, and the kind of whole point of going through all that is so that we have these we have some curves in 3D that we can kind of build off of. I'll copy this one as well. Okay. So if I go back to my top view here, that's my interp curve right there. So now we have these kind of curves that are like vertical, or these arches that are vertical, that we could start to use to generate surfaces. So, for example, if I wanted to like array a series of curves of a certain size, I could just copy this curve. Well, actually, the easiest way to do it would just be to extrude this curve directly. In Rhino, you can make any curve or outline into a surface by using the command extrude. So extrude curve, for example, we select any curve and press enter, it will automatically extrude a surface from that curve. Now you can see that normally extrude curve will work by extruding like along the z-axis in whatever viewport you're in. Like even if I drew a weird curve kind of like this, like a weird diagonal curve, if I were to extrude it in top view, it's still going to want to go in the z-axis like that. That's basically true for any curve that doesn't kind of adhere to a plane. So a single segment line, or like a line that has some weird geometry for some reason. Like that's kind of a three-dimensional curve. So if I extrude that guy, see, it's going to want to go in the z-axis. Now, anytime you extrude a curve, you can also you can set a direction like you do when you use a tangent. And so I can just trace a line here in my viewport. So now I'm extruding that curve in another direction. And you can see it just kind of makes that curve like into a surface, like a 3D surface. However, when you have an arch, which is like a curve that's already planar, so like it exists on a two-dimensional plane, when you extrude that, it'll automatically detect that the curve is planar, and it'll extrude it perpendicular to that plane. So we don't have to bother setting a direction. So if we wanted to turn this curve into like a kind of ribbon surface, we could do so by extruding it perpendicular, just like that. You can also extrude in both directions. So if you click this button, both sides, you can go like that. And when you extrude a closed outline, for example, if I draw a closed rectangle and go to extrude curve, and I'll turn off both sides, we have this option solid. Basically, that means when I extrude this guy, if I have that on, you can see it made a little closed end to my box, outline there. If I do that again with solid turned off, you can see I don't have a closed end, I just have an open kind of tube. Okay, and so basically you can kind of draw a series of ribbons by kind of like arraying arches or curves. Another thing we could do if we wanted to array a bunch really quickly is we could draw like a path curve. And I can go array curve. And so if I select the objects to array, that's my arch. And press enter. And then I select a path curve, which is that 2D curve I just drew. Change the number of them that I have. Click OK. It'll kind of like copy the arch that many times, and it'll keep the same orientation of that arch relative to the array curve. And then I could go one at a time, and I'd have to go one at a time to extrude them all in a different plane. And I could go both sides, and I could go to like 5 or something. That's great. And I could kind of go, and I'm just pressing enter on the keyboard twice to repeat the same curve, or the same command, the extrude command. You can see it also preserves the last dimension that I extruded it to, which is 1. I extruded a bunch of strips that are like 2 units wide along that edge. Okay, so that's one way you could make a bunch of strips or ribbons and kind of like lay them out. Another way you can do this would be to take the same curve, and let's say we wanted to, well, actually before I get to that, let's go back. So if I wanted to make a ribbon out of this surface in the other direction, I could use the command offset. So I think we use this in our 2D drawing tutorial, but if you take any planar curve, which these are, and type in offset, you can see we have the option to kind of offset them to the inside or the outside by a certain distance. So I can change the distance to like 1. And also choose this option cap. What cap does is it'll make a little connection between the endpoints of the original curve and the offset curve. And so I'm gonna leave that flat cap turned on, and I could then copy these. And so I'm making like closed planar outlines when I'm doing that. And in order to turn that into a surface, I can use the command, the second one under this planar surface button, which is called, what is it called? Called planar surf. And so basically anytime you have a closed planar outline, so that all the curves have to be joined and they have to be like on a single plane, you can use this command planar surf and make a planar surface. So if we wanted to make like a series of ribs in the other direction like that, we could do that using those that set of commands. Now the other thing I wanted to show you is like if you wanted to vary the curve, so I could copy this curve from the beginning to the end of my array curve And I'll do that by using the command orient. Just like in our 2D drawing, I'm going to choose the start and end point. I can choose the option to copy it and also choose the option to scale it. I'm going to go 3D. And then I can draw another arch at the end of my array curve there. You can see it copied it. It also changed the height of it and width of it. Then I could also scale 1D if I wanted to change it even more. Okay. And then let's say I wanted to make a series of curves that are kind of steps in between these two different curves. What I could do is actually make a surface and then extract the curves in between. So what I'll do is I'll use the command sweep 1. And sweep 1 is kind of like extrude, except it follows a path. So if I go sweep 1, I can select my rail. That'll be that array curve that I drew, that base curve. And then I can select a cross section. So in this case, I'm just going to show you what it does with one cross section. So if I press enter, you can see it's kind of extruding a surface along a path in a sense. But it's also like changing the orientation. So that's how I could create like a kind of tube-like surface based on that arch and a path curve. I could also use extrude curve along curve, use like a path. So that's the curve I want to extrude. That's the path. And so you see that one extruded the outline along the curve, but it didn't change the orientation at the end. So it didn't like change the orientation of the arch as it extruded. It just kept the same orientation, but extruded it along the path. But if I wanted it to actually change dimensions from this arch to this arch as it extruded from one end to the other, I can use the command sweep 2 and press enter. So I think in this case, we would treat well, maybe you can do it with sweep 1. Let me try it. Sweep 1. So this would be our rail, our path, or our array curve. And then it'll say cross-section curve, so I'll go 1 and then the other, so either one at the beginning and end. And then I'll press enter. Oh yeah, that does work. So you just need sweep 1. And you can see it extrudes one arch along the path to kind of fit into the shape of another arch. So it's kind of transforming the cross-section of that surface from one end to the other. And if I wanted to make it even more kind of varied, I could make another path curve, and then I would use the command sweep 2, and I would make these two flat curves my rail curves, and then I would make these two my cross-section curves, and then it would extrude that shape kind of along those two different that surface would kind of meet all those edges on the outside. Okay, this surface. And then to kind of do what I described before, in order to make a bunch of arches that, again, are kind of like steps in between the end and the beginning of this surface, I can actually extract curves, again, from this surface. And I'll do that by using the command extract iso curve. An iso curve allows me to extract a curve anywhere on a surface. And again, I can change my direction here. If I click on direction, I can go to V. I can change it to U. See, that shows me where the curves are in the other direction, the kind of orientation in the other direction. So I could make a bunch of curves kind of based on the surface. If I want to space them out precisely, I'll use the command divide, and I'll select my edge curve, and I'll set a number of divisions that I want to create, and then I press enter, and it creates a point evenly spaced with 6 separate divisions. I could do the same on the end curves. So, and then again, I could go to extract iso curve, select that surface, and I could go to and snap to each of those points that I just created with my divide command. I'm going to turn off intersect. Make sure you need to have your point snap on for that. And then I'll change directions here. Okay, and so we can create kind of a network of curves in 3D space, kind of based on a surface. Okay, let's see. So somewhat similar to what we just did with those three-dimensional curves and making like strips or ribs, we can also create surfaces by kind of arranging different curves in 3D space and then making surfaces through them. So I'm going to copy this catenary curve that I was using earlier, and you can make one of those just by using the command catenary. And remember, we drew it in front view, so it's vertical. It's like a vertical arch like that. So basically, you can make any kind of surface as long as through a set of curves, as long as you have the curves kind of defining spaces with 4 edges. So let me explain what I mean by that. So I'm going to copy this curve a few times by rotating it. So I'm going to type in the command rotate. I'm going to snap to one endpoint. Rotate it 90 degrees like that. And I'll do the same in the other direction. 90 degrees. Okay, so now I've made 4 identical arches that kind of define like the outline of a square in plan. So if I look at it in plan or in top view, you can see those are all planar, perfectly vertical arches. And so what we have is like a, kind of a space that's defined by 4 arches. And remember, they're all touching at the endpoints. That's important. So if I wanted to make a surface through these edges, I could use the command network surface. And I'm just going to select all 4 edges, and I'm going to press enter. And you can see it kind of makes a surface like interpolated through all 4 of those kind of edge surfaces. And so I'll click OK. And now you can see because I kind of clicked, because I only had edge surfaces, it just kind of took that cross section and followed it like along the other cross section, kind of like if we had swept these two, like if we had swept these 2 cross sections along these 2 rail curves in sweep 2. So in order to get a little more control over that surface, I could also add additional like subdivisions or additional curves. So like I said before, I'm just gonna, well, what I'm gonna do is I'm gonna copy this outline to the midpoint of each of my arches. Then I'm gonna go into front view. Where am I? And I'm gonna use scale 1D. I'll snap to the endpoint there. Now I'm scaling kind of in the Z-axis. And I'll scale that guy down to a smaller curve. Go back to top view, you can see it's a more shallow curve now. And then I can also rotate it and copy it. So rotate, snap to my midpoint there. Just rotate it 90 degrees again because my edges are a square essentially. I can rotate it and those curves are touching, right? The endpoints of that curve are touching the midpoint of each outside edge. So, and then if I took this set of curves and I created or did a network surf command through it and click OK, you can see now I have a surface that's kind of defined by those edges and by those surfaces in between it. So that's what I kind of mean by having to have 4 edges all the time. So it's like, if you look at it, for example, here, each little subspace of the surface has like 4 edges. Now, so for example, what I couldn't do is I couldn't here's my midpoint. Oops, start over here. So if I wanted to subdivide it the other way, you can see when I do that, what I've actually created is is a surface where like each subspace is actually defined by 3 edges. So for example, if I wanted, like this little space has 1, 2, and 3 edges, right? And so now if I were to try and make a network surface out of this, Rhino would not know what to do. So it'll first say unable to sort, then it'll ask you what curves you want to go in one direction, and it just won't be able to figure it out. It'll say unable. So that's what I mean by like making a network of curves that that move in 2 directions. There we go. Okay, cool. So that's kind of one method. The other thing you can do if you wanted to create like a different type of vault. So we could also create like kind of a groin vault, which is basically just an intersection of 2 extruded vaults. For example, if I take this curve and just use the command extrude curve there, and then I'm going to rotate it. And also, like when you drag in Rhino, you can tap Alt on the command line. I'm sorry, on the keyboard as you use the gumball, and I can copy something as I transform it. And so if I wanted to join these 2 into one kind of vaulted intersection, I could take one and I could type trim, and I'll click on the little inside surfaces there, press enter, and I'll take the other. Again, I'll type trim, and I'll click on the little inside surfaces and trim those away. So now I got like 4 intersecting kind of catenary vaults. If I join those together, and I'll go into, here, let me bring this back to, if I go into a rendered view here, you can see, first of all, you can see that this surface actually has no like seams in it. It's all one surface. However, this one does have seams, because it's actually composed of multiple surfaces that have been joined. And so that's where you see those kind of edges there, and that's why you see those darker lines in the shaded view. That's an edge, right? That's just my curve right there. Okay, so what I could do if I wanted to kind of blend the surfaces into each other is use a command called fillet edge. And if I take the edges of any joined polysurface, which is what this is, it's a multiple surfaces that are joined along the seams, and I'll click on those edges that are joined in between the surfaces, and I can set a radius. So fillet, remember, will make like a kind of arch between two faces. So I'll set a radius there. I can go, I'll just go like 1.5. And then I'll press enter and press enter again. And so you can see it took that edge, that kind of sharp edge of where the 2 surfaces met, and it made a kind of radiused surface in between them. And now, so importantly, this is still a poly surface. It's still like a joined set of surfaces, but it automatically created some new surfaces that kind of blended where our joints were between one vaulted shape and the other. So that's one way you could kind of create vaulted shapes. So the other thing I wanted to mention is that like other examples from certain case studies, we can make like ribbon surfaces by twisting. So for example, let's say I had a set of kind of curves that I wanted to make strips in between. I'm going to draw one curve like that. I'm going to draw, and I'm just going to copy it. Like with the move command, I can use the option vertical to move it up, move it by 10. Okay, so now I have two straight lines, kind of one right above the other, 3D. And I could make like a, let me actually divide these. So I could make like a line. Actually, I'm just going to get rid of these. I could make a line kind of at each point, right? I could make them at different angles. Kind of like the other twisting surfaces. Okay, and then if I wanted to make like a ribbon in between them, I could use the command loft. And so loft, let's see, loft, I don't know if we did this earlier or not, but basically loft kind of connects multiple surfaces as a series of segments. So like one thing you could do, for example, like one of the ways we could have made that surface earlier would be just to copy the cross section several times and kind of scale it each time and even like reorient it. And so in order to make a kind of surface that goes through all those, I can use this command loft. And if I type, or if I select 3 surfaces like that, it'll create a surface that kind of interpolates through multiple ones like that in a certain direction, just with cross sections. And we can do the same basic thing to create like ribbons or twisted surfaces like this, just with straight cross section. If I use the command loft again and go from one to the other, you can see when they're oriented the same, I get a planar surface. But as they start to rotate, I get like a twisted surface. So I could get kind of twisted surfaces that way. Now, one thing that you'll start to notice is as these curves become more and more rotated, it's not going to preserve like the kind of cross section. Let me actually copy this guy. It's not going to preserve like the width of the strip based on the curve you loft with. So, for example, if they're really kind of at different angles, and actually we just did that wrong. So what we actually want is for this to kind of twist from one to the other, not to go straight like it is, or like it has. When you loft something, it's also important which side of a curve you click. So for example, if I loft these 2 curves, I use command loft, and notice which end of the curve I'm clicking on. Okay, and so that gives me a straight kind of lofted surface between the 2. However, if I loft and I click on the 2 opposite ends, what happens is it twists the surface. It wants me to, it's connecting that end to that end and that end to that end and back and forth. And I could do the same through all those, so it would twist all the way through. So likewise here, it matters like which end of the curve I click closest to. So if I click on the end of the curve closer to the original point, it should twist it for me like that. So I'll click OK. But you'll notice that because these 2 curves now at the beginning and end are kind of angled far apart from each other, they're actually giving us like a really narrow cross section right in the middle. So like before, we could use sweep instead of loft. So I'll draw a straight line connecting the endpoint of those 2 end curves, and I'll use sweep 1. That's my rail, that vertical line, and those 2 end lines are my loft curves. I'm sorry, or my cross section curves. And perhaps if I click road-like, should preserve the cross section. Okay. Well, the other thing we can do here is we could add another curve that's rotated right in between these 2. And then we could add that into our loft sequence. So there you see we're actually preserving the width of the strip along the lofted ribbon. Now you can also see because of the way we've oriented them, one edge is straight and one edge is curving. Of course, if you wanted to do it kind of exactly like like the example, you would want the midpoint of each of these vertical lines to be like aligned along a central axis, like that. And then if we were to go loft, we go 1, 3, and then it would make a kind of symmetrical twisted surface like that. So you could kind of build a series of ribbons, twisted ribbons, that way. Okay, so I'm also going to do, at this point, I'm going to make a kind of larger surface, kind of like the vaulted ones we had before, using this loft command. So I'm going to make a series of circles and draw like a kind of vertical tube. I'll just use the command circle. And I'm using the object snap center. I'm making a series of circles of different size. Okay. And then I'll move these up. Go up by like 4. 4 again. And then maybe I'll copy this one above. This one. Gone way too far. Oh, okay. Okay, so I can make like I did before with the arches. I could select all these curves, these circles, and I could loft them and kind of create a tube or like a truncated tube that way. So I'm actually going to, well, I can just loft it right now and then scale it up. Why I'm showing you that is because once you kind of have a surface defined that you want to use to like create geometry. So for example, if you have like a surface pattern or like a surface geometry, you can actually like apply it to a 3-dimensional surface based on a 2-dimensional pattern. So to demonstrate that, I'm going to borrow a couple of the examples of the designs you guys have been doing. So I'm going to take this origami one, and I'm going to copy it a few times here. I'm going to scale it down a little bit so I don't need too much space. Okay, then I'll copy it. I'll make like actually I can array it. So I'll do like 4 in the X and Y direction, none or 1 in the Z direction. Because it's a square, remember when we drew it, I just go from one corner to the other. It should automatically multiply in a 4x4 grid. Of course, you can just copy it in rows as well if you want to. And then, so let's say I took this 2-dimensional pattern and I wanted to apply it to a 3-dimensional surface like this one or this one. Not 2-dimensional, but I took this like kind of geometry and wanted to apply it. I could take a, what I want to do is make a base plane. So I'm going to use the plane command, and I'm going to go corner to corner. And so I could take this geometry relative to its base plane and apply it to a 3D surface and using the command flow along surf. So I can select the objects that I want to flow. That's my little folded tiles there. And I'll press enter, and then I I select the base surface that I want to use. That's the plane that I just drew. Like when I loft, the corner that I actually click of that base surface is important. I'll explain that in a minute. And then it'll ask me for a target surface, and that's my 3-dimensional surface. And I'll click on this guy. Okay, so what happened is it did it, but it went on the inside of the surface. So one thing we have to be mindful of here, something that will often happen, change my